Good morning, students. Today we are going to solve some problems on Gauss elimination and Gauss Jordan method. Here you have a problem. Solve the system of equation by Gauss elimination method and Gauss Jordan method. The given equations are minus 3x1 plus 2x2 minus 3x3 equal to minus 6. The second equation is x1 minus x2 plus x3 equal to 1. And the third equation is 2x1 minus 5x2 plus 4x3 equal to 5. The given system of equation can be written in the order such that the coefficient of the first equation must be 1 so that you can easily solve the equation. So here what we have to do is we have to find out the values of x1, x2, x3. Now I am rearranging the given set of equation such that x1 minus x2 plus x3 equal to 1 minus 3x1 plus 2x2 minus 3x3 equal to 6. 2x1 minus 5x2 plus 4x3 equal to 5. Next step, we have to rewrite the given equation in the format of Ax equal to b, that is in the format of augmented matrix form. Okay, so here A given b is equal to, first you write the coefficients of x1, x2, x3 in a matrix form, and along with that put one straight line. Along with that you write the right hand side of the given set of equations. So see here, in first equation you have 1x1 minus x2 plus x3 equal to 1. So 1 minus 1 1 and your right hand side is 1. In second equation the coefficients are minus 3 2 and again minus 3 and the right hand side is minus 6. And see the third row, see the third equation, here it is 2 minus 5 4 and your right hand side is 5. So this is how to write the augmented matrix. Now our aim is to make the given matrix augmented matrix as an upper triangular matrix. So for that, in the first column the last element and the second element, make those two elements as 0. So for that what I am going to do is I am taking the row 2. So row 2 plus you have to multiply 3 with r1 so that you will get add with the row 2, so you can get the first element will be 0, so that you can get the first row is 0 minus 1 0 and minus 3. Now I am going to do for third row. In third row I am having 2, so I am going to multiply 2 with the equation row 1, so r3 equal to r3 minus 2 r1. So now you got 0 minus 3 2 and 3. So now I got two elements as 0 in the first column. Next I am going to make this minus 3 where it is in A32 position, so make that element as 0. So for that what I am going to do is r3 is equal to r3 minus 3 r2. So using these calculations I am getting that element also 0. So now I got an upper triangular matrix. Now use the backward substitution for getting the solution of x1, x2, x3. So see the last row, you have two elements as 0, then you have 2 and 12. So write it is like an equation so that you can get 2x3 equal to 12, which gives the values of x3, it is 6. Okay, next we move on to the second row, it is 0 minus 1 0 and minus 3. So using the equation you write minus x3 equal to minus 3. Now you got the x2 value, x2 minus x2 equal to minus 3. Now you got the value as x2 equal to 3. Next at last you come to the first equation, write that matrix format as equation. Here you will get x1 minus 2 minus x2 plus x3 equal to 1. So you know the value of x2 and x3, substitute here, you can get the value of x1. So now I got the values of x1 as minus 2, x2 as 3 and x3 as 6. So this is the method for Gauss elimination. So what we did, we rearranged the given equation such that the first element A11 element must be 1, the coefficient must be 1. So that is the first step. Second step is write that equation as a matrix format, that too in augmented matrix format. Then make that matrix as an upper triangular matrix, so that by using backward substitution you will get the solution. Next method is we have to solve the same equations by Gauss Jordan method. So Gauss Jordan method is make that augmented matrix as a diagonal matrix. So you know what is a diagonal matrix. So the diagonal elements before and after the diagonal elements must be 0. So for that same procedure I am going to follow. So see here, same I have written here the augmented matrix A B. So it is same thing I am getting. So same in first row, first column I am going to make the minus 3 and 2 as a 0 using the same steps what we have seen in your Gauss elimination method. And then I am going trying to make in your R1 row, that is A21, and also in R3 row 3 I am going to make A32 position. I am going to make those two elements as 0. Okay, so for that I am going to use in R1. So R1 row R1 plus R2, if you are directly adding you will getting that element as 0. And for R3 is equal to R3 plus 3R2. So multiplying 3 with the row 2 and adding with the row 3, I am getting that element A32 element is 0. So somewhat I am got the matrices 101 and 4, 101, I'm sorry, 0 1 0 3, and last row is 0 0 2 equal to 12. Now I am trying to make the A1/3 position as 0. So for that, so if you need any terms as common, you can divide that one also. So see here, R3 is equal to R3 divided by 2, so that I will get 0 0 1 and 6. Now R1 is equal to R1 minus R3. Okay, subtract that one, you will get the identity matrix for the augmented matrix or diagonal matrix or identity matrix. Here I am getting identity matrix. So direct substitution you can give x1 is equal to minus 2, x2 is equal to 3, and x3 is equal to 6. So this is another method to solve those simultaneous equations by Gauss Jordan method. This is a very easy method. So while you are using your Gauss elimination method, you have to use your backward substitution to get the unknown values. While you are using Gauss Jordan method, you have to use your normal diagonal matrix. That too in identity matrix means it is well and good. You can get the values of x1, x2, x3. Hope you have understand this one. We'll see with the next problem. Thank you.